The normal distribution is a fundamental concept in statistics, and in this video I show how to use it with the normal distribution table, like the one in the back of our book, and with R. This is a part of a normal distribution table when the z-value is negative. Z-values are usually shown down the left-hand column and across the top of the table. The left-hand column contains the first number to the left of the decimal point, and the first number to the right of the decimal point in the z-value. The numbers across the top of the table show the second number to the right of the decimal point. Numbers in the left-hand column of our book start with minus 3.9 and go to 0. This slide shows part of the table, starting with the z-value of minus 2.1 and going down to equaling z minus 1.7. Look at the highlighted row with z equaling minus 1.9 and the column with z of 0.06. The cells in the body of the table show the area to the left of z under a normal distribution. When z equals minus 1.96, the area under the curve less than this z-value equals 0.0250 of the area. Next, we're going to find the same area using the pnorm function in R. If you type $pnorm in R and run that line, R will display the help page for pnorm. This slide shows part of the information on the help page. When you look at the help page, you notice that there are 4 different functions. dnorm gives the density or height of the curve, pnorm gives the area, qnorm finds points along the x-axis, and rnorm selects random samples from a normal distribution. Let's look more closely at pnorm. The name of the function is pnorm, and the values inside the parentheses are called arguments. The first argument is q. This stands for quantile, and it's a value along the x-axis. The second argument is the mean, and it equals 0. This is the default value for the mean, so if you leave this argument out, R will automatically use mean equals 0. The third argument is SD. This stands for the standard deviation, and the default value is 1. At this point, notice that the default values for the mean and standard deviation are 0 and 1. This is the definition of the standard normal distribution. The fourth argument is lower dot tail, and the default is true in all caps. R is case sensitive, so you have to use uppercase letters for this. This argument means that R will find the area less than Q, which is the first argument. The fifth argument is log.p with the default of false. We will not be using this, so just omit this argument and R will use the default of false. This slide shows an example of using pnorm to find the area less than a z-value of minus 1.96. I only used one argument, and so the default values were used for the mean, which is 0, and the standard deviation, which is 1. Once again, this is the standard normal distribution. So the q value in the function is equivalent to a z-value. The area equals 0.025 rounded. Notice that you don't need to label the argument q. When you don't use labels for the arguments, R looks at the order of the arguments. The first argument in pnorm is q, so R used the first argument as q. The shaded area on this slide shows the area less than z equals minus 1.96. This is the part of a normal distribution table when the z-values are positive. When z equals positive 1.96, the area less than z equals 0.9750. Since the total area under the curve equals 1, the area greater than z equals 1.96 is 1 minus 0.9750, or 0.250. The shaded area on this slide equals the area less than z equals 1.96. To find the area between z equals 1.96 and z equals minus 1.96, you can subtract one pnorm function from the other. This is the same as saying 0.9750021 minus 0.0249979. This slide shows that the middle 95% of the area under normal distribution is plus and minus 1.96 standard deviations from the mean. And this slide shows the middle 95% of the area. In this video, I show how to find areas under the standard normal distribution using the normal distribution table and using the p-norm function in R. There are similar functions in R to find the area under two other probability distributions that we will use in this class, the t-distribution and the f-distribution. Thanks for watching, and please let me know if you have any questions.